This is the last conic we're going to do until we get into polar coordinates. So after these conics, we're going to go into polar coordinates, and then we're actually going to do these conics with polar coordinates, which sometimes you might consider easier and sometimes possibly not easier. So today what we're going to do is hyperbolas. And you see hyperbolas in a lot of places. One of the places that you see hyperbolas is in the amphitheater. So if you've been to, I always want to say Red Rocks because I lived in Colorado, but if you've been to the Gorge and also Red Rocks in Colorado, those are shaped like half a hyperbola, which is basically a parabolic shape. Not quite, but close to a parabolic shape. If you see any kind of nuclear cooling towers, which there's one in Washington on your way out, I think it's highway, I don't know what it is, goes out toward Aberdeen. Yeah, there's one out that way. They're also the shape of a hyperbola. The hyperbolas are used for long-range navigation systems, and they're used for doing locations. So here's what a hyperbola looks like at the origin. So with a hyperbola at the origin, and I don't memorize any of this stuff, and you can if you want, I don't, is that the one that's positive, so the variable that is positive, that's the variable in which you are going to hug, that axis. So if x is positive, then your hyperbola will hug the x-axis. If your y is positive, then you're going to hug the y-axis. Your vertices are still going to have that distance a from the origin. The difference between hyperbolas and ellipses is that a does not have to be the larger number. A is the one underneath the positive variable. We still go out some distance b, and the b is the value that's found underneath the negative variable. Our foci, right here and here, are always going to be inside of the hyperbola, inside that parabolic shape on either side. So we still have foci on this, but they're inside. And it doesn't matter who the larger number is. Unlike ellipses, I care about who the larger number is underneath. This one I care about what the larger number is, positive or negative. So your vertices, when you're on the origin, your vertices, if x is positive, will be plus and minus a comma 0. We have foci, and the foci is basically just our regular Pythagorean theorem. A squared plus b squared is equal to c squared, where the foci is, c is the distance from the center to the center to the foci is c. We have something called asymptotes on this one. So these, unlike parabolic shapes, they're not truly parabolic shapes because these have something called asymptotes. These are these lines in which we get close to, but not touch. So we end up with these lines and we call them asymptotes. Here's the equation for the asymptotes, and I still don't memorize those either. I'll show you why. I don't memorize any of this stuff. And then we have the segment from B1 to B2 is the conjugate axes. So let's go back up and show where B1 and B2 is. So they're saying this is the conjugate axes. So if you asked where's the conjugate axes, it's the axes in which I'm not hugging with my hyperbola. Any questions so far? Yes?
Will the center of this kind of hyperbola always be the origin?
Initially, yes. We're going to move off of it, though. We are going to move off of it. Yes?
When you said the positive variable is the one that we're going to be hugging,
Uh-huh.
It looked like that one was like curving in towards the y-axis.
So this is kind of a hug toward the x-axis, and this is kind of a hug toward the x-axis.
Okay.
And the x part is the one that's positive. So my y, when my y is positive, my hyperbola will be going in the other direction. It'll be going up and down instead of left and right.
Okay.
And they come in pairs, the left side, right side, and then up, and then the down. Okay? Yes?
So then, wait, does it matter if x is positive or not? It just matters if it's x?
No, so what matters is who's positive, right? So if x is positive, it's going to have that hug shape along the x, or parallel to the x. And then on my next example here, notice that on this one, my y is positive. Because my y is positive, I'm going to be hugging along the y, here and here. Because the y is now positive. It doesn't matter who's first or second, and it doesn't matter who's got the larger number. It's who's the positive one and who's the negative one. That's all that really matters. So if we are hugging in this direction, my c is still the same. It's still going to be a squared plus b squared is equal to c squared. The only thing that really changes is that my vertices are now along the y-axis. So instead of a positive, negative a, comma 0, it is 0, positive, and negative a. Instead of my foci on the previous one, which is positive and negative c, comma 0, now it's 0, positive, negative c. My asymptotes we're going to talk about, I mean, you can write that down and memorize it, but I just don't, and I'll show you why I don't. I'll give you an explanation in a moment why I don't. Here's all the formulas if you're inclined to memorize them or write them down, and I believe they're on your handout. Are they not on your handout?
How do you read that segment with the line over there? What's that?
The conjugate axes.
What's that line over the top?
That means I have a line. Actually, it's a segment. So that line across the top just means I have a segment and it's a conjugate. So you'll see the line across the top a lot for conjugate when it talks about a conjugate number. Like when you're doing complex numbers, if you have a complex number z, then z bar would be the conjugate of that. So you'll see that a lot with conjugate. And this happens to be a line segment, so it's a double duty. Does that answer your question? Well, this is your conjugate axes right here. Okay. Any other questions on these? Okay. So let's go ahead and graph these. I'm going to do B, and I want you all to do C, or A. So I'm going to do B, and the first thing is it has to be equal to 1. So I have to divide everything by 81. Excuse me, I'm sorry. So I'm going to divide everything by 81 first. And when I divide everything by 81, I'm going to get y squared over 9 minus x squared over 81 is equal to 1. Now I have it in the right form. So I know that my y is positive, so I know that I'm going to be hugging along the y-axis, and that's where my vertices will be on the y-axis, and so will my foci. So when I start to build my graph, on the y-axis, I'm going to go the square root of 9, so I'm going to go 3 in each direction. So right there is where one vertex is, and right there is where the other one is. So my first vertex is at 0, 3. My other one is at 0, negative 3. My conjugate axis is going to be the square root of 81, so I'm going to go 9 in each direction. So negative 9, 0, and then 9, 0. I am not ever going to memorize those formulas. What I do is draw a box. I draw a box that goes parallel to my vertex on the top and the bottom. And it also has to go through the sides. So I draw this box. The reason I draw this box is because from corner to corner through the center is where my asymptotes are. So from corner to corner through the center is where my asymptotes are. Those are my asymptotes. Again, I don't memorize it. I know my asymptotes are going to be this change right here, which happens to be 9, over this change right here, which happens to be 3. That's my slope. To get from the center to the corner, that's my slope. So I know that this equation, y equals, it's going to be 9 over 3, or in other words, just 3, or 1/3, 3 over 9, which is 1/3 x. Now, did I memorize that? No, I did not. I just counted from the center to the corner of the box. Doing my other one, y is equal to negative 1/3 x. So I don't memorize it. I don't know what a and b is, and I don't really care. What I care on hyperbolas is who's the positive one, and how do I get my box built. Now I just draw my hyperbola. It's going to go along these asymptotes and through that vertex. So it's going to go along the asymptotes through that vertex. So that's what my hyperbola looks like. The only thing I'm missing now is my foci. And c squared is going to be equal to my a squared, which is 9, plus my b squared, which is 81. So c squared is equal to 90. C is equal to 9, the square root, or 3, the square root of 10. Excuse me. So my foci are right here. My foci are at, why is that freaking out on me? As at 0, 3 square root of 10, and here 0, negative 3 square root of 10. Notice I didn't memorize anything. No memorization needed. All right, you all ready to try one? Do you want me to do another one first? What do you want?
Let's try that.
Okay, cool. So please do A. So let's go through B. The first thing I want to do with B is I want to erase this. Or excuse me, A, thank you. When I'm not feeling well, I'm not all there and I'm sketchier than usual. So I know it's so surprising, I'm so sketchy. And then when I'm sick, it's way sketchier. So let's go ahead and go through A. When we're going through A, the first thing we need to do is set it equal to 1. So I'm going to divide everything by 4. When I divide everything by 4, I'm going to get x squared over 4 minus y squared over 1 is equal to 1. Now, my y is negative this time. My x is the positive one. So that means I'm going to be opening left and right. So I'm going to go ahead and start the drawing of the graph. And so from the 0, 0, which is my center, I take the square root of 4, and that's how far I'm going to go in each direction in my x. So right here and right here. So my vertices are at the point 2, 0, and negative 2, 0. So those are my vertices are. I'm going to take the square root of 1 and go in each direction on the y. So I'm going to go up 1 and down 1. And from this is where I build my box. And I know my asymptotes are going to go through the box, corner to corner, obviously better than my corner to corner, also through the center. I know that this equation is just how did I get from the center to this corner. That's my slope. I don't have to worry about an intercept because it's going to go through the origin, so I don't have to worry about that part. So how did I go in? How far did I go up in the x, and how far did I go in the y? So I went 1 in the y, 2 in the x, and that's the equation of that one. Now, again, I am not memorizing anything. I'm just asking myself, how do I go from the center to the corner of the box? And then going from the center to this lower corner, y equals negative 1/2 x. Because my x is positive, I'm going to be hugging the x-axis, so I'm going to come in along there and come in, touch my vertex and along there. So that's what my graph is going to look like. The last thing I need to do is find my foci. To find my foci, I do c squared is equal to 4 plus 1. C is equal to the square root of 5. So it is square root of 5, comma 0, and negative square root of 5, comma 0. How was that? Yes?
I don't know if this is a dumb question, but how did you know that it was like that way instead of up and down?
Good question. So the reason I know that it is in the hugging the x's is because over here, my x was positive this time. And the way I always think about it is, do you want to hug a positive person or a negative person? Well, it's easier to hug a positive person. The negative person probably needs it more, but we usually hug the positive people because the negative people can punch us. So we try to avoid being punched, so hug positive people, and so that's how I know which way it's opening, as who's the positive one. Now I'm just going to talk a little bit about C, simply because of the fact that you're going to have something similar in the homework. If you haven't already finished 7.4, in 7.4 you're going to see some kind of fraction action going on. You're going to love every moment of it. So we're going to still do like we did before. We're going to divide everything by 1/4. So I divide this by 1/4, I divide this by 1/4, and I divide this by 1/4. What I end up with is y squared over 1/4, and I'm just going to leave it as over 1/4 because of the fact that I have to have my coefficient on y squared to be 1. And then minus x squared over 1/4, again, same reason, is because I need to have that coefficient on my x squared to be 1. And it's going to equal 1. Now when I draw this, it's obviously not going to be to scale. Which way am I going to open? Am I going to open up and down or left and right? And how do you know? Because y is positive. Because y is positive, we are going to be opening up and down. So let's come over here. And this obviously is going to be drawn to scale, as I'm going to go up 1/4, and I'm going to go down 1/4. So here is my vertices. And then I'm going to go left 1/4, and I'm going to go right 1/4. I draw my box. I draw my asymptotes through my box, corner to corner through the center. My equation here, well, if I went up 1/4 and over 1/4 is just 1, so just y equals x, and down 1/4 and over 1/4, so negative x. Yes? Oh, thank you. Magic of Markle makes that 1/2. You gotta watch me when I'm sick. I'm sketchy as hell. Okay, thank you for catching that. So 1/2, 1/2, 1/2, 1/2. There, look at that. Perfect. Perfect. Okay, so it doesn't change my asymptotes though. Now I'm going to go ahead and go along the asymptote through the vertice and back up through, along the asymptote through the vertice and back up through. So that's what my graph is going to look like, give or take. Now all I have to do is find out where my foci, thank you. So my c squared is equal to 1/4 plus 1/4. C squared is equal to 2/4, is that right? We're good? Which is equal to 1/2. So c is equal to the square root of 2/2 if you rationalize. The square root of 1/2, square root of 2/2. That's one number you should all be really familiar with by this point. So my foci here is going to be 0, square root of 2/2, and 0, negative square root of 2/2. Okay, how was that? That way you'll see the fractions here. Now, we are going to move off of the x-axis and the y-axis. When I move off of the x and the y-axis, My center now is h comma k, just like it was for a circle and or ellipse. So we're h comma k. My vertices, if the x part is positive, then I'm going to be hugging parallel to the x-axis, just like I did with an ellipse. In this case, it's positive, so I'm going to hug along the x-axis. I don't memorize any of that stuff. All of it's there. I'm not going to memorize it. I'm not going to refer to it. I'm not even going to look at it. I'm going to point it out in case you all want to write it down and waste some time. I'm not going to stop you. But really, you don't need to memorize any of this stuff. Not any ounce of it. So, when we go in the other direction, my y is positive. Still, I memorize not 1 ounce of this. Not 1 ounce of this. So let's just do one of them. Oh, look at that. Isn't that delicious? Look at that stuff. Which one of these would you like me to do? C. C? Okay, so let's do C. I'm going to do C over here. It is 9y squared minus 4x squared minus 18y plus 24x minus 63 is equal to 0. So the first thing I'm going to do is get my x's and y's together. Now, initially, who's positive to begin with? My y. So I'm going to put it first. I don't have to, but I am going to put it first. I'm going to put my y's together and my x's together. So 9y squared minus 18y minus 4x squared plus 24x. I'm going to bring that 63 to the other side. Now what I'm going to do is I'm going to give myself some space so I can complete the square. So I'm going to factor a 9 out of the first grouping, so y squared minus 2y plus some number minus 4. You've got to pay attention to this. I am subtracting out, I'm factoring out a negative 4. That means that that becomes not positive 6x, but negative 6x, because I'm factoring out a negative 4. So it is x squared minus 6x plus some number is equal to 63 plus 9 times some number minus 4 times some number. Why did I not add 4 and some number to each side? Because unlike ellipses, what I've done is I have a negative 4 multiplied by that number, so I need to balance that negative 4 times some number on the other side. So pay attention to your negatives. If you get it wrong, it's because you're not paying attention to your negatives and positives. Just like when I factored out a negative 4 here, this 6 is negative, not positive 6. Okay, so just pay attention to that part of it, and you'll be fine. Okay, so what do I need to add in the first grouping to get that to be a perfect square?
1.
So I'm going to add 1 here, and I'm going to add 1 here. What do I need to add in the next grouping to make that a perfect square? 9? So I'm going to add 9 here, and I'm going to add 9 here. So I have 9y minus 1 squared minus 4 x minus 3 squared. And then on the other side, I have 63 plus 9 minus 36. So tell me what 63 plus 9 minus 36 is. I think it's 36, but thank you. All right, how are we doing so far? Yes?
I'm confused, so when you put the square, how do you determine, add the 1 and the 9?
How do I know it's 1 and 9?
How do you know how to determine when it's
Okay, so the way in which I determine what I'm going to add or subtract is I take this number that's on the linear and the coefficient on the linear, in this case negative 2. I take negative 2 and I square it, and that's what has to go there.
Do you not divide it by 2?
Well, I take the negative 2, I divide it by 2, and then I square it. And the same thing is happening here. is I take this 6, this negative 6, divide it by 2, and I square it, and that's what's going to go there. I'm completing the square. All right, let me erase that just so it doesn't muddy down the water. So let me just get rid of that. And this. So the next thing I have to do is I have to divide everything by 36 because it has to equal 1. Unless it's equaling 1, it's not a hyperbola in standard form. So I'm going to divide everything by 36. And when I divide everything by 36, I get y minus 1, the quantity squared, over 4, minus x minus 3, the quantity squared, over 9, is equal to 1. How are we doing so far? Give me a moment to look at it in all of its delicious glory. It is pretty delicious. It is glorious. All right, so my center is at the point 3, 1. This is still h, this is still k, center is still h, k, even though it's switched being the y being first. Still h and k. So I'm going to go to 3, 1. That's where my center is. Which way am I hugging? Parallel to the x or parallel to the y? I'm parallel to the y. So I'm just going to put something here to remind myself I'm going in this direction, just to make my life easy. I know I'm going to be hugging in that direction. In fact, I'm going to be hugging that yellow line in a minute. So from the center, I'm going to go up 2 and down 2. So from this center, I'm going to go up 2. So if I've gone up 2, which part of my vertex over here is changing? The x part or the y part? The y. So if I've gone up 2, my vertex is at 3, 3, because I've added 2 to that 1. This is why I don't memorize it. And if I'm going down 2, which part of my vertex is changing? The x part or the y part? The y. So I'm going to go down 2. So my vertex here is at 3, -1. My box, I need to build my box. How far in each direction am I going to go in the x direction? 3. And I'm going to go 3 in each direction. So here and then over here. So now I'm going to build my box. And I'm going to go center to corner through the center. I'm going to draw my hyperbola. I do need to find each one of these asymptotes. And the equation of the asymptote is going to be y minus k. What is my k? 1 is equal to, again, I don't memorize it. How far did I go in the y direction? Because that's going to be the part of my slope I need for the delta y, or the change in y. How far did I move? 2. How far did I change in the x direction to get to that corner? 3. And then it's going to be x minus h. And there it is. And I didn't memorize anything. Memorize nothing. Get the other one over here. It is y minus 1 is equal to -2/3 x minus 3. Last thing I have to do is find my foci. My foci are going to be c squared is equal to 9 plus 4. C squared is equal to 13. C is equal to the square root of 13. My foci are going to be along that yellow dotted line. So am I going to add that to the x part or the y part of the center? The y part. So here's where my foci is. So it is going to be 3, 1 plus the square root of 13. My other one is going to be 3, 1 minus the square root of 13, wherever that happens to be. Excuse me. So I'm going to put this on pause, and I'm going to let you look at it, contemplate it, and then ask me if you have questions. Now, I said I didn't memorize anything, and I'm still not going to memorize anything, but note that this part of the equation of the asymptote is this part right here. This part of the equation of the asymptote is this part right here, unsquared. That's why I never memorize it. All I have to do then is just figure out how I got from the center to one of the corners of the box. Yes?
Why is the 2/3 negative?
Because it's a downward slope. Yes?
How did you get the y minus 1 equals 2/3 x minus 1?
So the equation of each one of these, first of all, I have to go through a point on the graph. I'm going to choose the center. Right? I have to, my equation of the line has to go through a point on that line. I'm going to choose the center. And then it has to have the slope. Well, the slope is just defined as the change in y over the change in x to the corner from the center. So this is just y minus 1 is just a point on the slope. That's y1 and x1. This is just a point slope form of a line. I'm given a point and the slope, and I just put in the point slope form. If I'm required to have a y equals, then I just bring the 1 to the other side and clean it up algebraically.
And the slope is 2 over 3?
The slope is 2 over 3 because I went up 2 over 3 from the center to get to the corner of the box. Yes?
And then it is positive.
One of them's positive, yes. One of them's negative. This one is positive because I'm going up the hill. So it has to be a positive slope. This one has to be negative because I'm going down the hill.
Did you write 2 answers then?
You have 2 answers, yes. Or you can do plus and minus. Depends on, WebWork will want it in 2. I don't care if you put plus and minus. Okay, how are we doing? You all ready to try one? Cool. Which one of these would you like to try? D as in dog? Cool, thank you. Do all 3 of them now, you got 7 minutes. Do D, please. Okay, so let's go ahead and go through D because I need to talk a little bit about eccentricity. So we're going to go through D, and the first thing we need to do is we need to get the x's and y's to the other side of the equal sign. So it's x squared minus 8x plus something. I'm going to put that in parentheses. And then minus y squared. And then because it's a plus, I'm adding 2y, but I'm factoring out a negative y, so it's minus 2y plus something is equal to negative 13. So what am I going to add with my first grouping? 16. So I'm adding 16 here and 16 here. What am I adding to my second grouping? But I'm not adding 1 to the other side. I am subtracting 1 from the other side. So do make sure you're paying attention to that. And that's because there's a negative right there. So I'm really actually subtracting that one off. So this ends up collapsing into x minus 4, the quantity squared, y minus 1, the quantity squared, and this equals 2, right? Is that equal 2? So I get 2, divide everything by 2, and I get x minus 4 squared over 2, y minus 1 squared over 2 is equal to 1. My center is at 4, 1. Which way am I orientated on this? I'm going to be hugging parallel to the x-axis, so I'm going to go to 4, 1. So 4, 1. So I am going to just draw a yellow line to remind myself that's where I'm going to be hugging parallel to. Yes?
Why did it become a +1 to a -1 when you collapsed it?
Here?
Yes.
So when I brought this over, I had x squared minus y squared plus, or it's going to be plus 2y minus 8x is equal to negative 13. So I'm going to reorder it so it's x squared plus or minus 8x.
I mean, a little bit lower, so.
I'm getting there. Why is this right there? Yeah, I'm getting there. I'm getting there. Trust me, I'm getting there. Give me a moment. And then I have minus y squared plus 2y Just like in my previous example, and I said, please make sure you are paying attention. I factored out a -4, that becomes a -6. I factor out a negative y, 1. So when I do that factoring, I have x squared minus 8x plus something. I am factoring out a -1. So that becomes y minus 2y. The only way that's a perfect square is if that would have been a -1 there. It's the only way that happens. All right, moving back to here, so I am going to go in each direction. I am going to go the square root of 2 in each direction. So I'm going to go square root of 2, square root of 2, square root of 2, square root of 2, draw my box. Be the best, quickest box ever. Do you see how great that box was? Here's my hyperbola, give or take. My vertices are going to be on the right side. Which one is changing on my center? My center is at 4, 1. Which one's changing? My y part or my x part for my vertice? My x part. So it's going to be 4 plus the square root of 2, 1. 4 minus the square root of 2, 1. So that's where my vertices are. My asymptotes are going to be, because I'm going to use the equation y minus y1 is equal to mx minus x1. I'm just using just a point slope. So I'm going to have, on this side, I'm going to have y minus 1 is equal to, because the distance in the x and y are the same, that's going to be just x minus 4. And then on this side, we have y minus 1 is equal to negative x minus 4. And all I'm using is a point slope formula. C squared is going to be equal to 4 plus 1. C is equal to the square root of 5. So who am I going to add that to? The x part or the y part of my vertex? The x part. So my foci are at 4 plus and minus the square root of 5, 1, because I'm lazy and going through it quickly. Normally I ask questions, but I'm not because I have to talk about this very, very quickly. So what eccentricity of a hyperbola is defined as c over a. This is important, c over a. The reason why this is important is because when I go and I'm asked to find the equation where I'm given the vertices and I'm given e and nothing else, they are given me c and they are given me a. So if they give me the eccentricity, they're giving me c and they are giving me a. If I want to find the equation with its given conditions, I'm going to draw a graph to figure out which way I am orientated. So I have the vertices at 3, so positive 3 and 7, so 3, 7, and then again at negative 3, 7. Which way am I orientated? If I have to go through these vertices, which way am I orientated? The x is where I'm orientated. I'm orientated toward the x. Now, if I'm orientated toward the x, that means it's going to be x minus something squared, and then it's going to be y minus something squared is equal to 1, and then I just have to figure out what goes underneath each one of these. How far did I travel between negative 3 and 3? 6. So I know half of that is my a, but it's also given to me right here. So I know that this is going to be 3 squared. But I do need to know where I'm going. Well, if half of that is 3, where is my h part of my vertex? Well, it has to be on that yellow line halfway between, which is right there. So that is 0. That's 7. And then all I have to do is say c squared is equal to a squared plus b squared. Find out what b is. So c squared, we're given, is 5, so that's 25 minus 9 is equal to b squared. 16 is the answer. There you go. Have a great day. Have a great weekend. This one's dead and put to bed.